Hello everyone. Good evening. Hope you all are doing great, guys. Today we are going to understand second routing protocol, that is EIGRP. EIGRP. So in last class yesterday we discussed RIP routing protocol, and today we are going to understand EIGRP routing protocol. Guys, in each routing protocol, the important thing that we need to understand is how that routing protocols calculate metric. Like if I will talk about RIP routing protocol, so in RIP routing protocol calculates their metric on the basis of hop count, right? In the same way, EIGRP will also have one mechanism for metric calculation, for best path calculation. So first of all, we will try to understand that how EIGRP router is going to calculate their metric. Okay, but before that, definitely I will tell you some important points, some basic points about EIGRP routing protocol. So let me show you. Here you can see some important point about EIGRP routing protocol, like EIGRP stands for Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol. And EIGRP is a combination of distance vector routing protocol plus link state routing protocol. That's why we are saying EIGRP is an advanced distance vector routing protocol. Advanced distance vector routing protocol that used on computer network for automatic routing decision. EIGRP protocol was designed by Cisco system. So earlier this routing protocol was Cisco proprietary, but nowadays this routing protocol is open standard, right? Because later on Cisco declared it as a open standard in 2013. Okay, so nowadays we can run EIGRP routing protocol on Cisco devices also and on non-Cisco devices also. Okay, because this is the open standard protocol nowadays. Okay, next thing is EIGRP is used on a router to share routes with other routers within same autonomous system number. Now question is, what is autonomous system number and what is the meaning of it? It means EIGRP works within AS, within autonomous system number. Within EIGRP works within AS number. Now what is AS number? We will see, we will understand what is autonomous system number as well. Okay, before discussing AS, see next point about EIGRP routing protocol is it is a classless routing protocol. Like RIP version 2 was classless routing protocol, and RIP version 1 is class full routing protocol. So EIGRP is a classless routing protocol. Here we have again option to enable or disable automatic summarization, but by default it is classless routing protocol. It can support subnetting and VLSM. Then what is AD value of EIGRP? So EIGRP uses two number of AD value. One is 90 and one is 170. 90 and 170. 90 is used for internal prefixes and 170 is used for external prefixes. EIGRP encapsulate their packets with IP protocol. IP protocol, and protocol number is 88. EIGRP is an layer 3 protocol. It is a network layer protocol, not application layer protocols like RIP. RIP is an application layer protocol. EIGRP is a layer 3 protocol, network layer protocol. So here we don't have any TCP or UDP protocol for EIGRP. Simply EIGRP using one protocol number to identify EIGRP packet, that is 88. Protocol number of EIGRP is 88. Okay. Then EIGRP support automatic summarization, as I told you. EIGRP also use hop count, but never select best path on the basis of hop count. By default, for all router where EIGRP is running has hop count defined as 100, and we can configure hop count from 1 to 255. From this range, we can configure any hop count in EIGRP, right? So these are very basic points about EIGRP. Now let me discuss how EIGRP routing protocol is going to work. Just give me 1 second, guys. See, let's say I have two router, R1, R2. First of all, as I told you, EIGRP work within ES number. Means if these two router belongs to same ES number, then only we can configure EIGRP, and then only EIGRP will work fine between R1 and R2. Let's say this is router 1, R1, and this is R2. R2, here my autonomous system number is 100, and here my autonomous system number is again 100. So in this scenario, EIGRP will work fine because both router belongs to same ES number, right? But let's say on router number 2, ES number is not 100, ES number is 200 on router number 2, and ES number on router 1 is 100. Then EIGRP will not work between router 1 and router 2. Fine. Now, if someone is thinking, what is autonomous system number? So let's understand with one example, guys. Let's say there is one society. There is one society. Name of this society is, let's say, XYZ. This is XYZ society. In XYZ society, there are few peoples are living in this society. Some families are living in this society. So whatever rule and regulation is defined for XYZ society will be same for all the people who is living in this society. For all the people who is living in this society, like water supply bill, or you can't enter in the society after 10 p.m., or you cannot what we can say, any rule, like you have to enter in society before 10 p.m., or you can't out from the society after 10 p.m. Whatever light bills are there, water supply bills are there, whatever rule and regulation is defined for XYZ society, that will be same for every person who is living in the society. Getting my point? Let's say here two people are living. One is this one and this one. These two people are living in the society. Let's say this is A, person A, whose name is A, person B. Person A, person B. Both are living in XYZ society. That means rule and regulation is going to be same for both A and B person, right? For A and B person. Now, how we will identify that person A and person B belongs to same society? I will ask to person A, hey, in which society do you live? He said, I am living in XYZ society. If when I will ask to person B, where do you live? He said, I lived in XYZ society. Then I came to know both person are living in XYZ society. That means whatever rule is defined for XYZ society will be same for person A and person B. So this society is similar like autonomous system. Autonomous system is what? A domain. Society is what? A domain area. Like that, autonomous system is also a domain where routing policy for all router will be same who is living in this domain. Let's say this is a domain. In this society, in this domain we have some routers R1, R2, R3. So routing policy, like rule in XYZ society was same for all the person, here routing policy for all the routers is going to be same in this autonomous system number. Let's say this is ES number 100. ES number 100, right? So all routers are living in this domain. All routers are connected in ES number 100. That means routing policy for all the router is going to be same. Now, how we identify two router or two routers belongs to same society or different society? With the help of ES number, with the help of autonomous system number. Like how we identify these two person belongs to same society or different society? With the help of society name, like that we can identify these three routers belongs to same autonomous system number or different autonomous system number, right? So now you can see here these three routers belongs to same autonomous system number. That means routing policy for all these three routers will be same, and here we can configure EIGRP and EIGRP will work fine here, right? But EIGRP will not work between autonomous system number. Let's say here we have one different autonomous system, and in this autonomous system again we have one router, and this is ES number 200. This is ES number 200. So we cannot configure EIGRP between ES number 100 and ES number 200. This is first concern about EIGRP routing protocol. So what I am trying to explain you, I'm trying to explain you that EIGRP work within autonomous system number. Autonomous system number should be same on two routers to form EIGRP neighborship. Otherwise, EIGRP neighborship will not come up. Fine. Now, how EIGRP routers will share autonomous system number with their neighbor? So let's say I have again two router R1, R2. R1, R2. Here, let's say IP address is 12.1. Here, let's say IP address is 12.2. Once I will enable EIGRP on router number one. Command to enable EIGRP is very simple. You will run this command router EIGRP and then autonomous system number. Let's say we are running EIGRP autonomous system number 100 on router number one. And after that, with the help of network command, we will advertise interfaces in EIGRP. So I will run network 12.1.1.0, right? Once I will hit enter, what R1 will do, R1 will start sending one hello message from the interface where this network is running. So this network is running on this interface. So router one will start sending hello message from this interface. What is the use of hello message? Hello message. Hello message. Hello message is used to discover neighbor. Hello message is used to discover neighbor. Router one is trying to discover one neighbor on this interface. On this interface, router one is trying neighbor. Dynamic neighbor discovery. Purpose of hello message is DND, dynamic neighbor discovery, right? And hello message will carry AS number information. So inside the hello message of router one, there will be AS number that is 100, right? R1 is sending hello message to R2, but on R2 we have not enabled EIGRP till now, so router 2 will discard that hello message. But when I will run this command, these two command on router number 2 also, like router EIGRP AS number 100 EIGRP and then network 12.1.1.0. Router 2 will also start sending hello message from the interface where this 12 network is running. That means from this interface, router 2 will also start sending hello message. Inside the hello message of R2, there will be information of autonomous system number that is 100. And when router 1 will receive hello message of router 2, it will check what is the AS number coming inside the hello message. So AS number coming in the hello message is 100 and AS number which is running on me is also 100. That means we can form a neighborship. Both router will decide we can form a neighborship with each other and then these two router will become neighbor. Then these two router will become neighbor. Router 1 and router 2 will become neighbor. After becoming neighbor, router 1 will share routing information. Routing information. Now we have neighbor ship between router 1 and router 2. Once router 1 and router 2 will form EIGRP neighborship, then router 1 will share their routing table to router 2 and router 2 will share their routing table to router 1, right? This is basic funda of EIGRP, right? Now I am going to show you guys these things practically. Let me open GNS3 and in GNS3 let me design one small lab here. Okay. R1 and R2. Here IP address is going to be 12.1.1.1, and on router number 2 IP address is going to be 12.1.1.2. Fine, let me turn on the device and let me access R1 and R2. First, I will configure IP addresses. Then I will capture the link just to show you hello message of EIGRP. Config T. And let's say router 1 is connected with one LAN also, like here we have one LAN. LAN network. If I will talk about RIP routing protocol, so if we will enable RIP on router 1 and router 2, once I will enable RIP, router 1 will share their routing table to router 2, router 2 will share their routing table to router 1, right? Without forming any neighborship. But in case of EIGRP, first two router will become neighbor, then router will exchange their routing table. So here we have one LAN also. Okay, let me configure IP on R1. Interface fast Ethernet 0/0, say no set. And IP address 12.1.1.1 255.255.255.0. Exit interface fast Ethernet 1/0, say no set. And IP address over here is 10.1.1.1 255.255.255.0. IP configuration on router 1 is done. Let me configure IP on R2. Interface fast Ethernet 0/0, say no set. And IP address 12.1.1.2 255.255.255.0. Exit. Fine. Now let me configure EIGRP. But before configuring EIGRP, I would like to capture the link between router 1 and router 2. So let me capture the link. Okay, now we are not able to see any hello messages here in the capturing because till now we have not enabled EIGRP routing protocol. So on R1, I'm going to run router EIGRP ES number 100. This command will allocate some memory to EIGRP ES number 100, and after that, with the help of network command, we will advertise interfaces in EIGRP 12.1.1.0, and then we can define wildcard mask as well, like 0.0.255, or you can ignore it. You can ignore it as well. Say no auto summary also, and then network 10.1.1.0. So we have enabled EIGRP on fast Ethernet 0/0 of router 1 as well as on fast Ethernet 1/0 of router 1. How we can verify? So IP protocol. By running command show IP protocol, you are able to see we are performing routing for this network and this network. We are performing routing for this network and this network. Distance, we have two distance value. Administrative distance 90 and 170. 90 is for internal, 170 is for external. Okay. Routing protocol is EIGRP ES number 100. Now in the capturing, you can see hello messages. See, router 1 12.1 is sending continuously hello message, right? Router 1 is sending continuously hello message. Hello timer is 5 seconds. So after 5 seconds, router is sending one hello message. If I will open any hello message, you can see inside the hello message, router is sending what? ES number, autonomous system number. Autonomous, there is information of version, opcode means which type of message it is. It is hello message, and then autonomous system number are there, right? But so IP EIGRP neighbor, this is command to check EIGRP neighbor table. We don't have any neighbor here, right? Because I have not configured EIGRP on router number 2 till now. Let me enable EIGRP on router 2 also. Router EIGRP as number 100, say network 12.1.1.0, right? And soon EIGRP neighborship will come up. See the log message. Neighbor 12.1.1.1 on fast Ethernet 0/0 is up, new adjacency. And now here we can run this command, show IP EIGRP neighbor. So you can see we have EIGRP neighborship between router 1 and router 2. And inside the capturing, you can see the update message also. After forming neighbor, once router 1 have formed neighborship, router 1 have sent update message. And in that update message, router 1 is sending which network information? It is sending 10 network information. Let me show you. This is null update message. Here is update message. This is update message. It is sending 10 network information 10.1.1.0/24, and this is how router 2 will learn 10.1.1.10/24 on router number 2. So IP route EIGRP, so IP route EIGRP, we are able to see this network, this D indicating EIGRP. D stand for EIGRP. Here you can see, correct. So this is basic configuration of EIGRP. Basic configuration, like how we enable EIGRP on sorry, routers. Okay. Now what is metric value? Metric value for this network is, you can see this one, 30720, and AD value is 90 because this is internal prefix. This is internal prefix, so AD value is 90 and metric value is this one. Now we need to understand how router 2 have calculated this value as a metric. This value as a metric. This is first video of EIGRP, brother. This is first class on EIGRP. Now we haven't discussed any things about EIGRP, just we have discussed basic configuration and basic points about EIGRP routing protocol. Like EIGRP is a layer 3 protocol. What is AD value of EIGRP? EIGRP work within AS, means within autonomous system number, and how to enable EIGRP between two routers. Now we are going to understand how EIGRP calculates metric. How EIGRP routers calculate metric. So see, in this scenario, by default, guys, EIGRP will use link. As I told you, EIGRP protocols use link properties to calculate metric. Distance vector routing protocol like RIP calculates their metric on the basis of hop count. RIP routing protocol does not use link properties to calculate metric, but EIGRP routing protocols use link properties to calculate metric. So here you can see this network 10.1.1.0/24 network is directly connected on router number 1. So once I will advertise this network in EIGRP, R1 will calculate one metric for this network. R1 will calculate one metric for this network by using link properties. On R1, we can check what is metric. So IP EIGRP topology. EIGRP routing protocol maintain 3 types of table: neighbor table, topology table, and routing table. First, EIGRP router will form neighborship. It will keep the information of neighbor in their neighbor table. After that, it will form topology table. Inside the topology table, it will install all possible network, and then by running algorithm, dual algorithm, EIGRP will calculate best path and it will build routing table. Okay, so let me show you topology table of R1. Inside the topology table, we are able to see two network, right? 12 network and 10 network. For 10 network, this is metric. FD is metric. FD is feasible distance. FD stands for feasible distance. This is metric. Question is how router 1 have calculated this metric for this network and this metric for this network. Metric is same for both network because both network is running on fast Ethernet 0/0. So like bandwidth and delay is going to be same on both interface. Okay. So by default, EIGRP uses bandwidth and delay value of link to calculate metric. Bandwidth and delay to calculate bandwidth. See, formula of metric is very simple. Formula to calculate metric is 10 raised to power 7 upon least bandwidth. Least bandwidth plus total delay upon 10 and whole multiply by 256. EIGRP is going to use this formula to calculate metric. EIGRP is going to use this formula to calculate metric. So let's say router 1 need to calculate metric for this network for 10.1.1.0/24. So router 1 will use this formula 10 raised to power 7 upon least bandwidth. So it will check what is the bandwidth of this link. So let me show you guys what is the bandwidth of this link also here. So interface fast Ethernet 1/0 and we can say include bandwidth. So you can see bandwidth is this one 10 raised to power 5. 10 raised to power 5 is the bandwidth of fast Ethernet 1/0, right? So here it will put router 1 will put this value in formula 10 raised to power 5 upon delay, total delay. Delay of this link is 100. Here you can see 100. So delay is going to be 100 here upon 10 and whole multiply by 256. Guys, please calculate it and let me know what value you will get. After this is 256. Here you will get 100 plus 10 and whole multiply by 256. 110 110 multiply by 256. What value you will get here? Hello. Please let me know what value you will get here in the chat or let me calculate it. Let me open my calculator. One one zero multiply by 256. I'm getting this value. You can see 28160. So this is metric for 10 network on router number 1. And same value we are able to see here also. You can see metric for 10 network is 28160. 28160. Right? So R1 will install this prefix in their topology table with this metric. After that, R1 will advertise this network to router number 2. And with the help of update message. Hello message is used to discover neighbor. Update message is used to share network information to neighbor. Right? So through update message, R1 will share this 10 network 10.1.1.0/24 network to router number 2. And in the update message, R1 will also share bandwidth value and delay value. Bandwidth of receiving interface, bandwidth of this interface, and delay of this interface. So bandwidth of this interface is 10 raised to power 5 and delay of this interface is 100. Right? When R2 will receive update message, R2 also need to calculate metric for this network. Again, R2 will use same formula 10 raised to power 7 upon least bandwidth. Least bandwidth means bandwidth which is coming in update and bandwidth of my receiving interface. Which bandwidth is least? So it will choose least bandwidth. So bandwidth which is coming in update is 10 raised to power 5 and bandwidth of my receiving interface is also 10 raised to power 5. Here you can see bandwidth of R2 fast Ethernet 0/0 is interface fast Ethernet 0/0 include bandwidth. So bandwidth is again here 10 raised to power 5. So bandwidth is tie, same bandwidth coming in update and same bandwidth is the bandwidth of my link. So it will use same value as a bandwidth, 10 raised to power 5, plus total delay which is coming in my update is 10 raised, delay which is coming in update is 100, and delay of my interface, total delay of my interface is also 100, right? So total delay is going to be what? 200. Total delay is going to be 200 here. 100 plus 100 upon 10 and whole multiply by 256, right? So here again we will get value 100. Here we will get 200 upon 10 means 20 and whole multiply by 256. So this is 120 multiply by 256. What value I will get here? 120 multiply by 256. I'm getting 30720. So for R2, what is metric for 10 network? 30720. Let me verify it. So IP EIGRP topology. Yes, you can see for 10 network R2 have calculated same metric 30720. Now can anyone tell me if R2 is connected with one another router R3? If R2 is connected with one another router R3, here R2 is connected with R3, then what will be metric on R3 for 10 network? What will be metric on R3 for 10 network? Please calculate guys metric on R3 for 10 network. Till then, let me configure the scenario. Between router 2 and router 3, I am using 23 network. Here IP address is 23.1.1.2 and on R3 IP address is 23.1.1.3. Let's say 3. So tell me what will be metric on R3 for 10 network. Router EIGRP as number 100, network 23.1.1.0 and on R3 config T, interface fast Ethernet 0/0, say no cert, and IP address 23.1.1.3 255.255.255.0 exit router EIGRP as number 100 and say network 23.1.1.0. Say no auto summary as well. And on R2 also we can run no auto summary. Now on R3, what will be metric for 10 network? So IP EIGRP topology. What will happen? R2 will calculate metric for 10 network. After that, R2 will advertise 10 network to R3 with the help of update message. With the help of update message. And R2 will share what? Bandwidth and delay. Again, bandwidth and delay. It is advertising 10.1.1.0/24 network. With in the update message, R2 will also share bandwidth. Bandwidth means least bandwidth. So till R2 list bandwidth is 10 raised to power 5 and it will advertise total delay. Total delay till R2 is 200. When R3 will receive the update message, R3 also need to calculate metric. By applying same formula 10 raised to power 7 upon list bandwidth. So bandwidth which is coming in update is 10 raised to power 5 and bandwidth of my link is what? Bandwidth of my link is also 10 raised to power 5 because we are using same link. So IP interface fast Ethernet 0/0 include bandwidth. Include bandwidth. You can see bandwidth over here is again 10 raised to power 5. So it will put this bandwidth value in formula. Am I audible? Is there any problem with network, guys? Is there a network problem? Please let me know if my voice and my screen is my screen visible and my voice is clear to you or not. Is audio and video okay?
Yes, no issue.
Yeah. So now R3 will put bandwidth and delay value in the formula 10 raised to power 7 upon 10 raised to power 5 plus total delay. Delay which is coming in update is 200 and delay of my interface is 100, means total delay is 300 upon 10 and whole multiply by 256. This is how R3 will calculate metric for 10 network. 100 plus 30 whole multiply by 256. So 130 multiplied by 256 is going to be metric on R3. One hundred 30 multiplied by 256. I'm getting this value 33280. Let me check. So IP EIGRP topology. Yes, for 10 network, router 2 is not receiving 10 network. So IP EIGRP neighbor. We don't have EIGRP neighborship between router 1 and router 2. Let me verify it. Ping 23.1.1.2. Let me ping my neighbor. So ping is also not working. I think there is some problem on router 2. So IP interface brief exclude unassign. So you can see this interface fast Ethernet 1/0 is unassigned and shut down. Let me configure IP on fast Ethernet 1/0 guys first. 1/0 say no set and IP address 23.1.1.2 done. Now EIGRP neighborship will come up. Yes, we have EIGRP neighborship now. And let me check topology table of R3. So IP EIGRP topology. So you can see for 10 network, metric is 33280. So hope now it is clear to everyone how EIGRP router is going to calculate metric. And list metric is always preferred. Done. So let's say I have one topology here. R1 is connected with R2 is connected with, let's say, R3. And here we have R4. And here we have one LAN 30.1.1.0/24. Let's say metric on this link is 5, metric on this link is 10, metric on this link is 20, and metric on this link is 10. Metric of this link is, let's say, 5. So router 1 will receive 30 prefixes from two sides, right? From router number 2 also and from router number 4 also. From both sides, router 1 will calculate what? Metric. From the upper path, total metric is 5 plus 5 plus 10 means 20. And from lower side, total metric is 20 plus 10, 30 plus 5, 35. So which path is best path for R1 to reach in 30 network? Upper path is the best path. Router 1 will install 30 network in their routing table via router number 2. Is it clear?
Yeah. Can you go back again? Can you go back again? Can you go back again?
Sorry, please type in chat.
Can you go back again? Explain this one again.
Okay. What I am saying here, let's say router 3 is connected with one network 30.1.1.0/24. So router 3, here we are running EIGRP routing protocol. Let's say EIGRP, yes, number 100 is running. So router 3 will advertise 30 network to router 2 and router 4. Router 2 and router 4 will advertise 30 network to router 1. Router 1 will calculate metric from both neighbor. Router 1 will calculate metric from both neighbor and it will compare. I am calculating list metric from which neighbor? So router 1 is calculating list metric from router number 2 from R2 neighbor. So best path is via router number 2. Best path is via router number 2. And if metric on both link is same, let's say metric on this link is also 10 and metric on this link is also 5. So now router 1 is calculating same metric value from both sides. Then router 1 will perform load balancing for this network. For 30 network, router 1 will perform load balancing. Router 1 will install both path in their routing table. Okay, so I am going to design that scenario here so that we can discuss some more features of EIGRP here. Let me design this topology: router 1, router 2, router 3, and let's say router 4. And router 4 is connected with one LAN. R1. Let me configure all routers. Between router 1 and router 2, I will use 12 network 12.1.1.0/24. Between router 2 and router 4, I will use 24.1.1.0/24 network. Between router 1 and router 3, I will use 13.1.1.0/24 network. And between router 3 and router 4, I will use 34.1.1.0/24 network. And here we are going to run EIGRPS number. EIGRPS number, let's say 100. Okay, now let me configure the scenario first. So interface fast Ethernet 0/0, say no set IP address 12.1.1.1 255.255.255.0. Exit interface fast Ethernet 1/0. Say no set here also, and IP address 13.1.1.1 255.255.255.0. Exit router EIGRP router EIGRP is number 100, and then network 12.1.1.0, and which network 13.1.1.0. Say no auto summary. Okay, exit do so history. Okay, so I have run these command on R1. Now let me configure R2. Interface fast Ethernet 0/0 no set IP address 12.1.1.2 255.255.255.0. Exit interface fast Ethernet 1/0. Say no set here also, and IP address 24.1.1.2 255.255.255.0. Exit router EIGRP as number 100, and let me advertise both network in EIGRP and network 24.1.1.0. No auto summary. So you can see we have EIGRP neighborship between router 1 and router 2. So IP EIGRP neighbor. So we have EIGRP neighborship, right? Now let me configure R3. Interface fast Ethernet 0/0, say no set. IP address 13.1.1.3 255.255.255.0. 0 exit interface fast Ethernet 1/0 54.1.1.3 255.255.255.0 exit router EIGRP as number 100 and network 13.1.1.0 and network 34.1.1.0. Now we have neighborship between router 1 and router 3 also. Now let me configure R4 interface fast Ethernet 0/0 no cert IP address 24.1.1.4 255.255.255.0 exit interface fast Ethernet 1/0 no set IP address 34.1.1.4 255.255.255.0 exit interface fast Ethernet 1/1 no set and IP address 10.1.1.1 let's say 255.255.255.0. Now we need to advertise these interfaces in EIGRP. So router EIGRP as number 100. And if I want to advertise all active interfaces in EIGRP, then I can run network command 0.0.0. This command will advertise all interfaces in EIGRP. Now we are expecting EIGRP neighborship between router 2 and router 4 as well as between router 3 and router 4. Yes, you can see neighbor is 34.1.1.3 means router 3 and 24.1.1.2 means router 2. Fine. So IP EIGRP topology. Inside the EIGRP topology table of R4, we are able to see 10 prefixes, 10 prefix, and what is metric? This one, 28160. Now router 4 will advertise it to router number 2 and router number 3 to their neighbor. So IP EIGRP neighbor. So router 4 have two neighbor. One is this one and one is this one. So router 4 will advertise 10 network to their both neighbor. So let me show you topology table of R3. So IP EIGRP topology. So yes, here also we are able to see 10 prefix on R2 also. So IP EIGRP topology, we are able to see 10 prefix and on R1. So IP EIGRP topology. And see guys, inside the EIGRP topology table, we are able to see two paths for this network. One is via router number 2 and one is via router number 3. Router 1 is performing load balancing. Why? Because you can see router 1 is calculating same metric value from both neighbor. Router 1 is calculating same metric from both neighbor. So router 1 is doing what? Load balancing. So IP route EIGRP. So for 10 network, you can see we have two next hop. We have two next hop. If I don't want to perform load balancing here, let's say I want to use upper path as a best path. So what I can do, I can increase some bandwidth on lower path. If I will, now router 1 is calculating same metric from both neighbor because link bandwidth and delay is same from both sides, from both neighbor. But if I will increase some bandwidth over here of this interface, or if I will decrease some delay of this interface, what will happen? Router 1 will calculate different metric from lower path. Router 1 will calculate different metric, right? So like this, we can change interface fast Ethernet 1/0, and here I can say bandwidth is, let's say 1000 kbps. And now show IP EIGRP topology. Inside the topology table, we are able to see how many paths? Two paths. But you can see this time metric is different from both paths. So router will install only one path in their routing table. So IP route EIGRP. In the routing table, we have only one path. Reachable. This network is reachable via router number 2. Now I am going to remove this command, interface fast Ethernet 0/0. Let me say no to this command. And again, router 1 will start performing load balancing. So IP route EIGRP. Yes, it is performing load balancing. Clear? Now router 1 is performing load balancing. It have installed two paths in their routing table because so IP protocol. Because this router can install maximum 4 paths in their table. But if I will configure maximum path 1, then what will happen? Then router can install only one path. either via router number 2 or either via router number 3. So we can change it by running this command router EIGRP as number 100 and say maximum path 1. Now, so IP route EIGRP. Again, you can see this network is reachable via 12.2. So IP EIGRP topology. Inside the topology table, still we have two paths with same metric value. But this time router 1 cannot install more than one path because we have configured maximum path 1. We have configured maximum path 1. Right? And how many paths we can configure? Router EIGRP as number 100 and say maximum path and put question mark. You can configure up to 32 path. Means one EIGRP router can install up to 32 paths in their routing table for a particular destination. For a particular destination, router can install up to 32 paths. Again, I am going to set 4 here. And so IP route EIGRP. Now again it have started performing load balancing. 1 minute. In EIGRP, there are many more things to learn, right? But as I told you here, just I am giving you one overview of each routing protocol. Here I am providing you just one overview of each routing protocol. By running command show IP protocol, you can see we have multiple features like we can, by default EIGRP is using only bandwidth and delay value for metric calculation, but we can use other parameter as well like MTU, we can use reliability, these parameter also for metric calculation. We have variance concept. This is part of CCNP, not CCNA. As I told you, maximum hop count that's allowed by default is 100. Maximum path is 4. We are performing routing for 2 network here, for 12 network and 13 network. These are gateway and distance value. This is router ID of router 1. And we can define router ID manually as well. Debug IP EIGRP packets. EIGR debug EIGRP packets. So you can see router 1 is sending hello message continuously to their both neighbor after every 5 seconds. But if you want to change this timer, you can change it. There are two use of hello message. One is to discover neighbor and another use is keep alive. It is checking that my neighbor is still alive or not by sending hello message. On all. How to change timer? Interface fast Ethernet 0/0 IP EIGRP IP hello interval for EIGRP as number 100 and then whatever time you want to set. Let's say 10 seconds. So now router will send hello message after 10 seconds, not after 5 seconds. 5 seconds is by default timer. In the same way, we can change hold on time also. IP hold on time for EIGRP as number 100 is let's say 50 seconds. Like this, we can manipulate timer. Like this, we can manipulate timer. After that, router EIGRP as number 100. And if you will put question mark here, you can see you have lots of options, right? You have lots of command to run here in this mode. No auto summary or automatic summarization. Address family is not for you for now. We can define default metric, default information originate. We can configure distance value like in this scenario, so IP route EIGRP. Router 1 is performing load balancing for 10.1.1.0/24 network. Router 1 have two paths. Okay, but let's say I want that router 1 should install this network from upper path only. So what I can do, I can increase some distance value from lower path. I can increase some distance value from lower path. How? Router EIGRP is number 100 and say distance. Distance, let's say 100, and from which source? From 13.1.1.3 wildcard mask 0.0.0. So whenever router will receive any network information from this neighbor, it will set distance value 100, right? And now if you will check again routing table of EIGRP, you can see we have still two paths. Just wait for some time, so it will update their table. Now you can see router 1 have only one path. So IP EIGRP topology. Inside the topology table, still we have two paths. But inside the routing table, we have only one path. Why? Because distance value from lower path from router number 3 is 100 and distance value from router number 2 is 90. If upper neighbor will goes down, if I will down link between R1 and R2, then it will install this prefix via router number 3, 10 prefix via router number 3. So IP route EIGRP, and you can see here distance value is what? 100. Right? So lower AD value is always preferred. Again, I am going to run no such command on fast Ethernet 0/0. Again, EIGRP neighborship will come. Yes. And so IP route EIGRP. Again, best path is via which router? Via router number 2. Just wait for some time, soon it will update their routing table. Yes, now you can see 10 network is reachable via 12.1.1.2 because it have list distance value. How to verify how many command I have run for EIGRP? We can run this command. So run pipe section EIGRP. EIGRP. So these are the command. So if I will remove this distance command, again it will start performing load balancing. Router EIGRP is number 100. Say no to this command. So IP EIGRP. So IP route EIGRP. Soon it will start performing load balancing. Now you can see it has started performing load balancing again. Now what next command? Router EIGRP ES number 100 and put question mark. We have discussed distance. Distribute list is for route filtering. Here we have option to run EIGRP. Like if I will run EIGRP here, EIGRP and then put question mark. So this is also not for you. If you want to configure router ID, like route EIGRP router ID of router 1 should be, let's say 1.1.1. So here we can run this command EIGRP router ID 1.1.1. And so IP protocol. Now what is the router ID of this router? 1.1.1. Earlier router ID was 13.1.1.1, right? Router EIGRP is number 100. Again, let me put question mark. You can see we have multiple option, maximum path. We can define metric. We can call to a particular neighbor. We can run network command. Here we can configure passive interface also. Like on R4, if I will debug R4, debug EIGRP packet. So see R4 is sending hello message from LAN interface also from fast Ethernet 1/1. Hmm. EIGRP receive hello message, send hello message from fast Ethernet 0/0 from fast Ethernet 0/0. See, it is sending hello message from fast Ethernet 1/1 also, right? But R4 should not send any message of EIGRP from fast Ethernet 1/1 because this interface is connected with switch LAN, right? So here we don't need EIGRP hello message. So what we need to configure? Passive interface. So first of all, let me disable debugging, and then we can configure router EIGRP S number 100, and then passive interface fast Ethernet 1/1. Now router 4 will stop sending message of EIGRP from fast Ethernet 1/1. Now if you will debug EIGRP packets, now you can see it is not sending any hello message from fast Ethernet 1/1. Now it will not send any message of EIGRP from fast Ethernet 1/1 because fast Ethernet 1/1 is configured as passive. Concept of passive interface is similar like distance vector routing protocol. Let me say unall. You can see it is not sending hello message from fast Ethernet 1/1 now. Now after that, router EIGRP is number 100. And again, let me put question mark. So we have passive interface, we have redistribution option, we can run shutdown command, summary metric, we can use timer command, and we can change variance value. This is also not for you. So we have these all options, these all command to run in this mode. So IP EIGRP topology. This is topology table of R4. So IP EIGRP neighbor. This is neighbor table of R4. And so IP route EIGRP. This is routing table of EIGRP. Now I want to show you something here. Let me download EIGRP PDF. This PDF is for CCNP student, but don't worry. Let me show you some important thing here. Yeah. EIGRP, Enhanced Interior Gateway Routing Protocol. It uses dual algorithm, diffuse updating algorithm to calculate best path. Like interviewer can directly ask you this question, EIGRP is using which algorithm for best path selection? So dual algorithm, always keep in mind, dual, diffusing update algorithm. There are four terminology of dual algorithm. One is FD, another one is RD, third one is successor, and fourth one is feasible successor. Feasible successor. FD means feasible distance. Feasible distance is total distance from source to destination. Total distance from source to destination. RD is total distance from a neighbor to destination. Successor means best path, and feasible successor means backup path. So these are four terminology of dual algorithm. Okay, then EIGRP will form neighbor relationship with adjacent router in same autonomous system number only. EIGRP traffic is either sent as unicast or as a multicast on this address. 224.0.0.10 is reserved for EIGRP. Right? This multicast address is reserved for EIGRP. 224.0.0.9 is reserved for EIGRP. Sorry, RIP version 2, and .10 is reserved for EIGRP. EIGRP router do not send periodic update. It send only hello message periodically, right? EIGRP router will send update message only once or whenever change will occur in the topology. Okay, then it is a classless routing protocol. That means it can support VLSM, AD value, is 90 for internal, 170 for external. It uses bandwidth and delay value for metric calculation by default, but it can use reliability also, load also, and MTU also. For that, we have to configure it manually. Right? We have to tell to router, please use reliability, load, and MTU for metric calculation. After that, EIGRP has maximum hop count 224 and by default 100. EIGRP maintain three types of table: neighbor table, topology table, and routing table. Neighbor table, EIGRP routers for neighbor table with the help of hello message, and it will keep the information of neighbor in neighbor table. And this is the command how you can change hello timer. By default, hello timer is hold on time is 3 time of hello timer. So let's say hello time is 5 seconds. That means hold on time is 15 seconds. If you will configure hello time 10 seconds, automatically hold on time will be configured as 30 seconds. 3 times of hello time. Thus, high speed link on timer is set to be 15 seconds, and on the slower WAN link, the timer is set to 180 seconds on the serial link. Okay, and this is command to change hold on time. After that, you have EIGRP neighbor information. Okay, router EIGRP log never change. Okay, this is not for you. This is part of NP. Now you can see in this scenario, router H is connected with one destination network. So router H will advertise destination network to their all neighbor. Their all neighbor will advertise prefixes to router B, C, and D, and router B, C, D will advertise network to router number A. And these value are metric. Now you can calculate which path is the best path for destination network. Which path is going to be best path for destination network. So FD from upper path is FD means total distance from source to destination. 6 plus 2 plus 8 means 16 is the what? FD value, total distance from source to destination. RD will be what? Total distance from my neighbor to destination. Neighbor of R1 is, router A is router B. So distance from router B to destination is 6 plus 2, 8. So RD will be 8 over here on this link, on the upper link. On this link, FD will be 9 plus 14 plus 4. RD will be 14 plus 9. On the lower link, FD will be 4 plus 5 plus 2. RD will be 5 plus 4. RD means distance from my neighbor to destination, and FD means total distance. Then EIGRP topology table. EIGRP packet type. So we have multiple types of messages in EIGRP. First message is hello. So what is the use of hello message? First use is DND, dynamic neighbor discovery, and second use of hello message is keep alive, to track my neighbor is alive or not. Second type of message in EIGRP is update message, which is used to share network information to neighbor. Third message is query message. Query message is used to inform and ask to their neighbor about network change. Let's say I have a topology here like this, R1, R2. R1 is connected with one LAN 10.1.1.0/24. Here we have EIGRP neighborship, right? So R2 will advertise this 10 network information to their neighbor to R2. Let's say after some time, if this network will goes down, if this network goes down, or this link failed, then what will happen? R1 will remove this network information from their topology table, and then it is responsibility of R1 to inform their neighbor also to remove this network information from their topology table. So with the help of query message, router 1 will inform to their neighbor, please remove this network information if you have installed or if you have learned this network information via me. And another use of query message is router 1 will ask to their neighbor also that if do you have any alternate path available for this network, then please share with me also, right? This is use of query message. And let's say router 2, when router 2 will receive query message, then router 2 will give reply with the help of reply message. Reply can be positive or negative. If router 2 have alternate path, let's say router 2 is connected with one another router R3, and R3 is also connected with this network, this LAN. So this time R2 can generate a positive reply for R1. R1 can share alternate path to R2, can share alternate path to R1, right? And after that acknowledgement message. EIGRP is a completely reliable protocol. So whenever EIGRP router sent update message, query message, and reply message, it will expect acknowledgement, right? Whenever router will receive update message, it will generate acknowledgement for that message, because EIGRP is a reliable message. Here also you can read about these all messages, like what is the use of hello message, update message, query message, reply message. Okay. Then EIGRP states. So we have two states. We have two states in EIGRP, active and passive. Guys, now if you will check topology table of, let's say, any router R4, so IP EIGRP topology, EIGRP topology. See, inside the topology table there are some prefixes, and all prefixes state are passive. This P stands for passive. Passive state means these networks are stable. These networks are stable. Topology is stable. And if, let's say, this network will goes down, right? First of all, router will put this network information in active state. Active state means my topology is not stable. My topology is not stable. So we have two types of state in EIGRP. Active and passive. Here also you can read about active and passive also. Then EIGRP metric calculation. We discussed how EIGRP router is going to calculate metric. Then basic configuration of EIGRP. And we can define bandwidth percentage also, like EIGRP should use only 30% of bandwidth, or EIGRP should use only 50% of bandwidth, like this, by running this command. See, on R1, on fast Ethernet 0/0, I want that EIGRP should use only 30% of bandwidth. So I can run this command, IP bandwidth percentage for EIGRP as number 100, and then define the percentage, let's say 50%. So now EIGRP will use only 50% of bandwidth on this link, fast Ethernet 0/0. These are again basic configuration of EIGRP between two routers. Then passive interface configuration. Then automatic summarization. We can enable or disable automatic summarization. And how to verify automatic summarization is enabled or disabled? By running show IP protocol command. By running show IP protocol command. Here you can see automatic summarization is disabled. Automatic summarization is disabled. Okay. Then we have manual summarization also in EIGRP. Like guys, in this scenario, so IP route EIGRP. Router 1 is performing load balancing, right? For 10 network. But let's say I want to forward traffic in 10 network via router number 2. So what I can do, I can advertise one summary route of this network via router number 3. On router number 3, interface fast Ethernet 0/0, here I can run this command, IP summary Address for EIGRP as number 100, and then summary address is 10 dot, let's say 0.0.0. Subnet mask is 255.0.0.0. Now router 3 will advertise this summary route instead of advertising individual prefix 10.1.1.0. Now if you will check again routing table of R1, so IP route EIGRP, you can see router 1 is not performing load balancing this time. This time router 1 have learned this summary network from router number 3 and this individual network from router number 2. Okay, hope it is clear. Next thing is EIGRP authentication. So if you want to configure authentication, so you can use this command. Authentication is similar like rerouting protocol. Again, here also you need to create one keychain, then you need to define key number and key string. Key string should be same. After that, EIGRP load balancing. So EIGRP load balancing is also not for you, but you can see here we have some command like we can use variance or we can configure maximum path. By default, maximum path is 4. So we can configure maximum path 2, 4, 6, like 5, whatever maximum path you want to configure. This part is basically not for CCNA candidate. Load balancing is not for CCNA candidate. This is for CCNP candidate. Then EIGRP step is also for CCNP candidate. Now we don't have anything in EIGRP. These are verification command. So interface is show IP protocol, show IP route, show IP route EIGRP, debug EIGRP neighbor, debug EIGRP packet, debug EIGRP route, debug EIGRP summary. Okay. So this is EIGRP second routing protocol. In next class, we will see last routing protocol of CCNA, that is OSPF. And guys, OSPF is very important routing protocol. Okay. So today we seen how EIGRP routing protocol works. Now, if anyone have question, please ask me in chat. Recording is available, guys. After class, CDP network will send you a recording of this class. So if you have any confusion in matrix calculation, you can watch the video again. If you need this file, I am sharing this file also with CDP network. Any question? This is more than sufficient for CCNA candidate. Radio server topic in upcoming class. No, brother. K1 is K1 is bandwidth and K3 is delay. K2 is reliability. By default, EIGRP uses K1 and K3 value, metric and delay. K1 is, sorry, bandwidth and delay. K1 is bandwidth and K3 is delay. What is stuck in active state? Okay, see here. In this scenario, when this network will goes down, right? R4 will generate one query message to ask to their neighbor, what if you have installed this prefix via me, please uninstall it from your table. And if you have any alternate path, then please share with me also. right? And it will put this network information in active state, 10.1.1.0/24. If this router will not get reply message from their neighbor within 180 second, then this router will put that network in active, stuck in active state. Then this router will put this network in stuck in active state. Stuck in active state means router is waiting for reply message for a particular network. Okay. Anything else? I'm requesting to CDP network, please share a link for Google review. In next class, we will see OSPF routing protocol. OSPF is, guys, important protocol for interview perspective, for exam perspective.
Hello. Hello.
Hello.
Hello.
Yes, yes. Hello.
Sir, what is the role of ADC in this protocol?
ADC, AD
Yes.
value. Where is
Okay.
ADC?
AD value is different from Active Directory.
Active Directory is different. This is concept of Windows Server.
Yes.
We are learning EIGRP routing protocol. EIGRP routing protocol is a dynamic routing protocol to share routing information between routers. Right.
Okay. Thank you, sir.
There is no comparison of ADC with EIGRP. Okay, guys. Bye bye then. Let's meet next Saturday. Thanks for joining.